Okay, direct substitution property. If f is a polynomial or a rational function, and you've got a number in the domain, then the limit as x approaches a for that function is just equal to a. So if you look in your homework at page 111, that's how you are going to answer question number 1. Limit as x approaches 3. Is 3 in the domain of this radical function? 3 squared, 9 plus 3, yes. So I can just use the direct substitution property. 3 squared plus 3 gives me root 12 or 2 root 3. Okay, so you can use direct substitution in 3 cases. So here is case number 1. When you do direct substitution, you get a number over a number. That's your limit. Even if you get 0 over a number, all works. This is the easy case. Case 2. If you get a number over 0, direct substitution won't work because you've got a 0 in the denominator. What does this give you? A vertical asymptote. That means you now have to figure out if the limit is going to positive or negative infinity. Remember, in this case, your limit doesn't exist. Case 3, you get 0 over 0. And this is going to make you work. Okay, functions with the direct substitution property are called continuous at a. However, not all limits can be evaluated by direct substitution. Okay, so back to the example we did in the beginning. Limit as x approaches 1, x squared minus 1 over x minus 1. We cannot use direct substitution, or we get an undefined function, 0 over 0. However, we can replace the given rational function with a continuous function that's equivalent. How do we do that? Just like we did in Math 12. Factor the numerator, and then look at this. Numerator and denominator have a common factor, which means we know we have this domain restriction, x can't equal 1. And what happens at x equals 1? We've got a point of discontinuity. What are the coordinates for the point of discontinuity? Well, if x is 1, I would have 1 squared. No, sorry. If x is 1, the coordinates for the point of discontinuity come from our simplified function. So once I cross off my common factors, I end up with x plus 1. If I put it in here, I get 2. Those are that's the coordinate for my point of discontinuity. So if we're looking for this limit, we factor, we simplify, and now we can evaluate using direct substitution. So in general, if f at x equals g at x, when x is not equal to a, then their limits will be identical.